Hi, welcome to my video on the inverse of a cubic and a cubic root function, part 3. I made up an extra question to do more work on the cubics and the cubic roots, but then in this one I combined a cubic root with a square root and do the inverses. So f of x equals the cube root of x minus 4. The h of x is equal to the negative square root of x minus 2. So notice the cubic root, and this is a square root. Find the intersection of the inverse f to the negative 1 and h to the negative 1. So let's look at the f of x is equal to the cube root of x minus 4. Because it's a cube root, the x belongs to the real numbers domain, y belongs to the real numbers, which is the range. So to find the inverse, I change the f of x to a y. Now I'll switch the y to an x and an x to a y because I'm reflecting in the line y equals x. Now I have to solve for y. So because that's a cube root, I have to cube both sides. So we cube this side and we cube this side. So that's x cubed equals the cube root of y minus 4 cubed is y minus 4. So y is equal to x cubed plus 4. So that's f to the negative 1 of x is equal to x cubed plus 4. And being an inverse, the domain and range are switched, but since both domain and range are the same, it's going to end up to be the same. Because they're reals, these are reals. Now, let's look at the equation. The h of x equals the negative square root of x minus 2. In this equation, we got a square root, so we can't have a negative underneath the root. So x is greater than or equal to 2. So that means the domain x is greater than or equal to 2 because it starts. So what you do is say x minus 2 is greater than or equal to 0. So x is greater than or equal to 2. That's the domain. And the range, there's a 0 on the end, so the y value starts at 0, but is negative, so the y value is less than or equal to 0. So that's the domain and range of the f of x, which is a square root function. So we change the h of x to a y. Done. We switch the y and the x's. Done. And now we'll solve for y. So we'll do the negative of each side. So negative x equals the root of y minus 2. And we'll square both sides now. So negative x squared is same as x squared. And the square root of y minus 2 all squared is y minus 2. So y is equal to x squared plus 2. And so h to the negative 1x is x squared plus 2. And we switch, so the range is the domain, so x is less than or equal to 0, and the domain is the range, y is greater than or equal to 2. So that's the inverses. So we got to say that the f to the negative 1 of x is equal to the inverse of the h. So that means that x cubed plus 4, which is right here, is equal to x squared plus 2. Now we've got a cubic equation, so let's do all the variables on one side in descending order. So it's x cubed minus x squared plus 4 minus 2 equals 0. So that means x cubed minus x squared plus 2 equals 0. So notice that we have a cubic, and a cubic has 3 roots. The power of highest power is 3, so we have 3 roots. So what we do, let's check it out by doing a table. And in the unit on polynomial functions, I discussed how to solve these by finding the positive reals, negative reals, imaginaries, etc., based on the power. So what I'm going to do is write down reals and positive. I'm going to write down reals, negative, and I'm going to have imaginary roots, and we have t for total. So there are 3 roots altogether, so that we know there's a total of 3, but there's several possibilities. And one is, if I look at this is for x, the number of sign changes indicates the number of positive real roots. So that's a plus going to a minus, so that's one sign change. That's a minus going to a plus is another sign change. So there's 2 possible real roots, but they go in increments of 2. So we can have 2 real roots or no real roots. Now we'll look at the negative. So if we do the negative x subbed in, so let's do a negative x subbed in the place of x, and that gives me a negative x cubed. Negative x squared is x squared, so there's a negative x squared, and plus 2. Now I don't need to equal 0, just write it down. So there's no sign change here, no, but there's 1 here. So we have 1 negative root, possible negative root. So therefore we have, if there's 1 negative, so we got 2 reals, 2 positive reals, 2 negative reals. That means we have no imaginaries, so the total is 3. We have a negative, we have no reals, and we have 1 positive negative root. That means we have 2 imaginaries for a total of 3. So we could have 2 real positive roots with 1 imaginary, 1 real, 2 positive real roots, or 1 negative real root, no imaginaries. Or we could have 2 no positive real roots, 1 negative, and 2 imaginaries. So let's see if we can do some work. Now we have to look at this equation. So the equation, again, put the equation in here so we won't get mixed up. X cubed minus x squared plus 4, plus 2, so we won't get mixed up. There it is, right there, there's the equation, equals 0. So this is the equation I got to look at. So what happens in this equation, the possible rational roots, I'm going to write down possible rationals. Possible rational roots are plus minus the factors of 2 over the factors of, let's write down factors here. So the factors of 2 over the factors of 1. So that means we have plus minus, the factors of 2 are 1 and 2. Factors of 1 are 1. So that means the possible rational roots is plus or minus 1 divided by 1 is 1. And 2 divided by 1 is 2. So the possible rational roots are plus minus 1 plus minus 2. So we have to look at, are the 2 reals. So what we do, we look for the roots. So let's look for, if 1 is a root, let's look for 1, if 1 is a root. And we tell if 1 is a root if we add up the coefficients. So if the sum of the coefficients is 1 minus 1 plus 2. So the sum of the roots is 2. So because the sum is 2, 1 is not a root. Now we check with the 2. So let's do a 2. Again, we got, could be 2 2s, but we just check. So we'll go with synthetic division. So we'll put a 2 there and a bar. And now we put x cubed, x squared. Notice there's no x, so we got to go over to 0, and we go over to 2. So we'll do synthetic division because it's way easier than the long division. Bring down your 1. 2 times 1 is 2. Negative 1, add on 2 is 1. 2 times 1 is 2. Add 2. 2 times 2 is 4. That gives us 6. So the remainder is, that's the remainder. And this remainder is not 0. So therefore 2 is not a root. So we don't have any more positive roots. So that means that we don't have 2 positive reals. So it's not this situation. It must be this. So there must be 1 negative. So now we'll try with a negative 1. And we'll go with a negative 1. So we'll take the negative 1 as a root, and we'll put into, again, this right here, 1, negative 1, 0, 2, which is this line here, 1, negative 1, 0, 2. Draw a line, bring down your 1, multiply. Negative 1 times 1 is negative 1. Negative 1 added up is negative 2. Negative 1 times negative 2 is 2. Add up 2. Negative 1 times 2 is negative 2. Add, we got a 0. So I always do this. So that's circled there, that's my remainder. Since my remainder is 0, negative 1 is a root. So that means we have 1 negative root, so we must have 2 imaginaries. So if there are 2 imaginaries, let's check to see if there's 2 imaginaries. Let's take this equation right here. So we have this equation, which is x squared minus 2x plus 2 is equal to 0, because this is what's left. This is a constant, a linear, and a quadratic, so that's an x squared minus 2x plus 2. So that means that's the A, that's the B, and that's the C. How do I know if the roots are going to be imaginary? Not relying on this, because I forgot to do this. My discriminant tells me if I have imaginary roots. So discriminant is b squared minus 4ac. That's underneath the root in the quadratic formula. B is negative 2. A is 1. And C is 2. So that gives us 4. We square first. Product, negative 8. So that's a negative 4. So because the discriminant is negative, that means we have 2 imaginary, if I can spell imaginary, we have 2 imaginary roots. So we only have 1 real root, which is negative 1. So let's take the h, let's take this equation here, the h of x equals x squared plus 2. That's the same as y equals x squared plus 2. And we take x equals negative 1 and sub in the place of x. So we get y equals 1 plus 2, y is 3. So if x is negative 1, y is 3. That's the point at which these 2 inverses will intersect. And there's no others, because there's only 3 roots. 1 is real. These are 2 imaginaries. We don't need the imaginaries, because we won't intersect at the imaginaries. So let's continue. Let me explain that using the geometry. F to the f of x equals the cube root of x minus 4. Its inverse we found out on the previous page. The f to the negative 1 is x cubed plus 4 reals. So let's take a table of values, and we can use any values of x we want. So let's use a 0. Put a 0 in here and I get a 4. Put a 1 in here and I'll put a 1 in, and I'll have 1 into but this is the inverse. 1 cubed is 1 plus 4 is 5. Put 1 in, put a 2 in. 2 cubed is 8. Plus 4 is 12. Put a negative 1 in. Negative 1 cubed is negative 1 plus 3 is 3. Put a negative 2 in. Negative 2 cubed is negative 8 plus 4 is negative 8 plus 4 is negative 4. Put negative 2 in, I get a negative 8, right? 4. Now, let's graph this cubic. So we have x is 0, y is 4. We have x is 1, y is 5. X is 2. We got a 12 right there. X is negative 1. Y is 3. X is negative 2. X is negative 2. Y is negative 4. So it comes down. Remember, it's a sideways S, curls in, and there it is, coming down through. There's a sideways S. This is the F of negative 1. This is inverse of this one. Now we do the table of values for, this is the table of values. This is F to the negative 1. And this is table of values for H to the negative 1. So H to the negative 1 is right here. So we'll take the values, and it says that the values of x are less than or equal to 0. So we take a 0, plug a 0 in here, and I'll get a 2. We plug a 1 in, less than, the values of x are less than 0. So we got to go 0, negative 1, negative 2. Put a negative 1 in here and square it. Negative 1 squared is 1. 1 plus 2 is a 3. Put a negative 2 in. Negative 2 squared is negative 2 times negative 2 is 4. 4 plus 2 is 6. So what I'm going to do is, right now, I'm going to do that color in to show its inverse. This 0 gives me a 2. Make sure that I'm going to do the inverse in red. Negative 1 is a 3. Negative 1 is a 3. And negative 2 is a 6. Negative 2 is a 6. So the inverse, notice that x is, I can keep going. So there it is there. So this is h to the negative 1 of x. So notice the point of intersection. This point right here, x is negative 1, y is 3. So that's the question, the answer to the question, but I did it algebraically on the previous page, part of the video, and this is doing it geometrically. Now, apologize, my arm moving there. What if the f of x was the cube root of x minus 4, which is the same as this, and the h of x was x minus 2. Notice the h of x here was the negative of this root. Now we have the positive. So what would be the intersection with these two when we look at its inverses? Well, let's have a look. The f of x, the inverse, we worked out the inverse. And they're the same. So therefore, without doing a lot of work like I did before, f to the negative 1 right here is the same. It's x cubed plus 4. Because that's the same as that, so that's the same answer. And we have x belongs to the reals, and we have y belongs to the reals. So it's the same answers right here. But let's look at the inverse of this one. The inverse of this one is, again, y. The h of x is changed to a y. We interchange the y and the x. We square both sides. X squared equals y minus 2. Y is equal to x squared plus 2. So the the h to the negative 1 of x is x squared plus 2. But here, when we did this one, right here, x is greater than or equal to 0, and the y is x is greater than or equal to 2, and the y is greater than or equal to 0. So the x starts off at 2 and goes up because we can't have a negative. And the y, this is a plus, so the y's are going to be greater than the 0. 0 is on the end. So 2, 0 is the point that starts off the graph of this. So the x's are greater than or equal to 2, and the y's are greater than 0. So knowing that, I'm going to put that right here. X is greater than or equal to 2, and the y is greater than or equal to 0. And there, you can see that's the inverse. So therefore, now we got the inverse. The x is greater than or equal to 2, so that means the y is going to, we've got to flip them. And the y is, the range is the domain, to make sure. So notice the domain here becomes the range. So I almost made that error. And the range in the h of x becomes the domain in the h to the negative 1. So x is greater than or equal to 0, and y is greater than or equal to 2. So if we look at that, so notice that, let's go back to these two equations. Notice that x cubed plus 4 and x squared plus 2, that's solving this is when the f to the negative 1 and h to the negative 1 are equal. But notice these two equations are the same as we had previous. So that means x cubed minus x squared plus 4 minus 2 equals 0. So we end up with the same equation that we had before. When we solved this equation going through the synthetic division and possible rational roots and all that, we ended up with, we found that x was negative 2, x was negative 1, and we had 2 imaginary roots. So we found that on the previous page, x was negative 1, and we had 2 imaginary roots. So we found that that was in the previous one when it was a minus here, as in here. But in this case, we have, what happens? We got x, notice that, again, right here, we have x is greater than or equal to 0. So in this case, we have to use the right side, x is greater than 0. So notice x greater than 0? No, don't work. So that means if we got x is negative 1 imaginaries, they're not fitting what this is saying. So that means there's no solution. There's no solutions. And that means there's no intersection. So let's look at the graph of it and explain it. What we have is the f of negative 1 is still the same. It's right there, same as here. There's the graph. But its inverse is right here. And we have the inverse. I'm going to do the inverse in green just to distinguish it. I'm going to have x and y. But the x has got to be greater than or equal to 0. So we've got 0, we got a 1 and a 2 and etc. So if x is 0, put a 0 in here and I get a 0 plus 2 is 2. If x is 1, 1 squared is 1, 1 plus 2 is 3. And we put a 2 in, 2 squared is 4, 4 plus 2 is 6. So this is the inverse of this part here. So we got 0 gives me a 2. 0 gives me a 2, which is here. 1 gives me a 3, which is right here. 2 gives me a 6, which is right here. And so if I draw that inverse, notice that there's no intersection. That means there's no solution to these when you make these two inverses, which are here and here. So there's this cubic graph and this inverse. This is h to the -1, but it's the green one. This is the other one that I did in red going to the, this is the one going to the left. This is the one where the x's are going to the right. So there's no intersection. So I thought I would make this question up. Hopefully I didn't confuse you. But having the h of x the negative and having the h of x the positive, again, you can see how the cube intersects when you go to the left with its inverse. It's one point of intersection. When you go to the right, there's no point of intersection. So I thought that was interesting when I seen that question. I had to do both pieces to explain why on the left side it's intersecting at one point, and on the right side, which is x greater than 0, there's no intersection. So I explained it algebraically and geometrically. So that brings us to the end of the video, and it brings us to the end of the unit that I'm doing on inverses. The next video will be on a review of all the videos on this unit. And click on the like button if you like my video. Click on the subscribe button if you're not a subscriber. You wish to subscribe. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, one word. Thank you for viewing my video. Hope the video was some help to you. Bye-bye.